Welcome back, ladies and gentlemen, for another YouTube video, all in crypto here. And today we are going to be talking about Polkadot Jam. Now, Jam is a mechanism that is essentially set to replace Polkadot's relay chain and actually enhance the features that the relay chain offers. What we're going to be doing in this video is we are going to be going over to a Twitter space that was put on by Polkadot's official Twitter page. And of course, they had Gavin and a number of other speakers that were involved in this, actually explaining Jam in a little bit more detail. I think Polkadot is one of the harder blockchains to kind of get your head around. So as much explaining of it as possible that we can share with you guys is, I think, really going to help. And I think as Polkadot sets its face towards Jam and the implementation of Jam, really understanding it is going to be of importance because it's going to give Polkadot an advantage in many different areas. Polkadot got a hell of a lot of things right. If we look at the direction that most blockchains are heading in, it is to not do everything on the layer one, but to have a kind of ecosystem of multiple blockchains that can carry out multiple tasks and scale kind of vertically with the spinning up of more blockchains to deal with more tasks. Polkadot essentially got that concept 100% right from the start. And I think this really came from Gavin Wood, of course, being instrumental in Ethereum and the various different stages of it. Actually, Parity itself was called, I think, ETHDev or ETH Core at one point. And then, of course, sort of leaving Ethereum and taking with him the lessons learned to essentially build Polkadot, which was a vision, now is a very successful blockchain. It successfully has managed to run 52 different blockchains, have them all interoperate with one another through the underlying consensus, which is the relay chain. And we are seeing the evolution of that because I've had a number of businesses, and when I first set those businesses out, often a year, 2 years into it, I've realized that I needed to do things in a different way. And actually, that's kind of what's going on with Polkadot with the implementation of Jam. So what I want to do is play a couple of clips from this, some longer than others, but hopefully it's going to give you a bit more insight into what Polkadot is currently going through and the direction in which it's taking. Let's start things off with a kind of recap for those of you that are unfamiliar with Polkadot in regards to what Polkadot actually is in its current state, and then we'll look at how Jam is going to change things.
This is a very interesting question. Polkadot, as it stands today, is largely an implementation of what was presented in the Polkadot paper back in late 2016, which is a scalable, heterogeneous multi-chain. What this means is that it's a bunch of chains that are sort of glued together through a common consensus protocol, and these chains can interoperate without fear that one of them can go awry and cause problems on the others in quite the same way that you would get if they were all under separate consensus systems. Now, the idea was to create, was actually the basic idea of Polkadot was built on an assumption that was never really properly vocalized, which is that this multi-chain architecture was just the natural next step in the evolution of blockchain. It's like, well, we've got one blockchain and it's sort of like Bitcoin and it does a particular job, and then we say, well, there was Ethereum and now it can do lots of different jobs owing to this sort of Turing complete EVM, Ethereum virtual machine, that it's built upon. And then Polkadot comes along and it's like, right, this is many different blockchains, each in principle running on the same VM. In our case, it was WebAssembly, but sort of able to handle, one would expect, a particular task more effectively perhaps than others. And so you start seeing app chains pop up, domain-specific chains. And as I say, this was just a general assumption that it would be the next logical step, sharding. Now, in reality, I think over the last 5 years, what we've learned is that it's not necessarily the next logical, that specific architecture is not necessarily the next logical step, and that's what Jam is here to address. But in principle, what Polkadot was always sort of meant to be, as it were, is a big, hefty, scalable computation engine that works in consensus, that is secure, that is resilient, that can process an awful lot of transactions.
So this idea of Polkadot basically being like a giant global computer, I think, is a really good idea. And it's a general purpose computer that uses distributed ledger technology to essentially allow individuals to carry out tasks in a trustless, asynchronous nature that can basically build upon what the internet was trying to do. It's very clear to me that a lot of the companies on the internet will eventually come over and start building in the Web3 world. And actually, Polkadot has really positioned itself, and certainly with the implementation of Jam that's coming up, to be this real general purposed machine compute that is going to enable people to do whatever it is they want. And I think Polkadot already has some insane use cases on it. Just the other day, we actually covered Mandala Chain, that is working with the government of the fourth largest country in the world by population to actually facilitate digital IDs and everything that can come off the back end of that. That's just one of many of the different things that are taking place on Polkadot. Many of the different tasks these parachains are undertaking, and of course utilizing Polkadot's cores to do this. We're now going to get this kind of breaking down of the barriers to entry in regards to the Polkadot space with the implementation of Jam, to the point where anybody can build on this general purpose, extremely scalable, secure, multi-billion dollar of security, in fact, blockchain. Let's now dive over to what is a longer clip. I'm actually Gavin Wood talking about Jam and kind of explaining it. And then we'll listen to his kind of summary of how could you really compress down the explanation of Jam and what it's trying to do.
Yeah, so as I was sort of saying, the original, largely unstated goal of Polkadot was really to be this, very scalable shared computer. Now, the fact that it took the shape of a quote unquote scalable heterogeneous multi-chain, bit of a mouthful that one, but it describes quite succinctly what it was that we were trying to deliver back in 2016, 17, 18. Is sort of the fact that it took that shape wasn't that was our best guess, certainly my best guess, for what shape it should take in order to deliver this scalable big compute resource. Broadly speaking, when I say this scalable big resilient compute resource, what I'm talking about is a blockchain that delivers lots of block space, right? That's, if we're going to sort of cut to the chase, block space is this term that sort of come up over the last few years, describing computation that is done without the need to trust someone. And then we can measure the quality of block space, like just how much don't we need to trust someone? Just what different things can this block space be used for, and so forth. And we can also describe how much block space there is, largely in terms of maximum throughput and cost. Now, the idea is to basically have nice big numbers for those, and that's really what Polkadot, although the term hadn't come about when the Polkadot paper was written, but that's really what we were aiming for with Polkadot. Now, it turns out that having lots of blockchains, and them each being secured under the same umbrella, under the same consensus mechanism, isn't necessarily the best way to go in order to deliver high quality block space. This is now, having built it, this is now a reflection on that. And the reason that I say this is very simple. It's called state partitioning, or state segmentation, or state fragmentation. Now, state is basically the stuff that's left over after you've done lots of all of your transactions, all of your computation. You end up with this. It takes some state to begin with, and you end up with some state afterwards. You can think of it as like your account balance, or what NFTs you happen to hold, or the current status of your insurance contract, or whatever else. It's the stuff that's left over after the transaction is finished, that can be drawn up again when a new transaction is going to begin. Now, having lots of state is very important for a blockchain to work properly. Basically, if you have a limited amount of states, then you can only process so many, or only hold so many user accounts. You can only hold so many insurance contracts, only hold so many account balances, and so forth. So you want lots of state. You also want lots of transactions, but that's a separate thing. Now, state fragmentation is basically what is forced on you if you adhere to the sort of general Polkadot design. Now, this is not purely Polkadot. A few other systems have done this. Basically, if you see systems that have many different blockchains and scale through sort of spinning up more blockchains, this is sort of what's going on there. And what it does is it says, well, some bits of the state can interact fundamentally and persistently, more cheaply, more speedily than other bits of the state. So basically, what we're doing is we're taking this state, which can be a huge amount of data, and partitioning it up, and saying basically it's fine as long as you're working within your partition. But if you ever want to work across partitions, then it's going to get slow, it's going to get expensive, and it's going to get a pain. And if it just so happens that all of the state that you need for the stuff you want to do doesn't fit into one partition, then kind of screwed. You kind of have to come up with very clever ways of like partitioning anyway, and then sucking up the costs. And what we see with this partitioning is that when you go across the partitions, you have to use special languages to do it, special programming techniques. For example, in Polkadot, it's XCM. You have to use sort of asynchronous programming techniques, and basically everything becomes quite a lot harder to do than if it's in the same partition. What Jam brings is the ability to not have to have persistent partitioning. Now, we still need to parallelize. We're still going to scale out, right? So what that means is that we're still going to have to divide and conquer. We're going to have to divide up our workload into different partitions and process it. But what Jam provides is an ability to not have to have those partitions be persistent. We only partition for an instant of time before basically everything goes back into the big lake of state, and things can be repartitioned in some different way the next point in time. And this is a step change in blockchain design. It's in particular, it facilitates a number of paradigms that we wouldn't otherwise be able to achieve if we just do this persistent fragmentation.
This is what I mean. Very complex blockchain, Polkadot, but essentially what we've got going on is right now with all these parachains, the kind of resources of Polkadot as a whole are kind of siloed, not the right word, but partitioned into individual, very rigid things. Whereas what Jam is all about is basically you're still going to have the partitioning or spinning up of these various chains. Cores is really how you want to look at them, like cores in a computer. But instead of them being permanently paralyzed or permanently partitioned, not because they are still paralyzed, you're going to have a breaking down of that. So Polkadot Jam is really going to introduce this kind of like an actual computer rather than multiple different computers that are all connected to one computer, if that makes sense. So it's going to become this big resource, and then you're going to be able to kind of partition things as you go along. And partition just means separate, basically. And it's going to make Polkadot a lot more general purpose than it already is, and allow anybody and everybody to build in it and it all to interact and kind of harness one another to that kind of next level. It's a real paradigm shift in the blockchain space. Gavin Wood then did kind of summarize this and give a kind of real term. We'll play that and then we'll wrap the video up. I just thought I absolutely had to share this. It's the most recent kind of talk Gavin Wood's given on Jam and kind of Polkadot and where it's at. And certainly I thought it would be good for viewer entertainment.
It's a little bit like, let's have a think. It's a little bit like, suppose you have a workforce. Now, you might have 1,000 people in the workforce. You could divide those 1,000 people in the workforce up into 1,000 companies. Each company handles, I don't know, some particular contracts with another company or whatever. But you've got these company walls, and it means that if you're an employee of the company, you're going to stay an employee of the company. All of the information regarding that company is going to reside sort of just with you, not with anyone else, right? Now, that's not how a large company works, right? A large company doesn't just subcontract out to 1,000 smaller companies. No, instead they actually hire 1,000 people and have them all sort of work together, splitting up the job, the work that they need to do, as needed, as in an efficient way. And if they do it efficiently, then they're going to be able to accomplish an awful lot more than 1,000 one-person companies, each with their very high cost for interaction with each other, would be able to do. And Jam is basically facilitating this 1,000-person single company rather than what we have at the moment, which is sort of 1,000 one-person companies.
So it's going to be an extremely interesting time for Polkadot as we look to roll out Jam. And, it's going to be very exciting to see just how well Polkadot can position itself with this upgrade, you could call it, that essentially is going to enable it to become more general purpose than it already is and really become a blockchain resource, a Web3 resource for people to build upon and build that next killer use case. And I think Polkadot stands a damn good chance of capturing multiple killer use cases utilizing blockchain technology. Ladies and gentlemen, that is it from me. I hope you enjoyed this content as much as I enjoyed delivering it. On that note, I'm going to love and leave you. Thanks a lot for watching. See you all in the next one.